Today we're going to look at our warm-up routine just so that you kind of know how our day starts in math class most days, probably with the exception of Fridays. Students should come in, they should get a copy of this from the cart. Sometimes they will choose a challenge, or the other sheet would say reteach. The idea is that they really build on the same concepts. Reteach is really the foundational skills, while challenge problems are really an application, or like a word problem, something that they have to think a little bit more so about. So this is just an example of our warm-up number 9 that we did in class. Students are expected to give me a first name, last name, tell me what hour they're in just because it helps me in the grade book, and then also the date. If you look, the directions say solve the problem below. Be sure to show all work. Well, let's read this one together. Lisa's making an activity basket. Oh, no, she's making activity baskets to donate to charity. She has 12 coloring books, 28 markers, and 36 crayons. What is the greatest number of baskets she can make if each type of toy is equally distributed among the baskets? How many of each supply will go into the baskets? One of the first things I want students to realize, I have 2 question marks. There are 2 parts to this problem. So, part A, or part 1, what is the greatest number of baskets? Greatest number reminds me of something. They should be thinking it reminds them of GCF, or greatest common factor. Next up it says, how many of each? So how many of each is the second part? Okay, how many of each will go into the basket? Part 2. Well, they give me a bunch of things. They give me this coloring book idea. So 12 coloring books is important. They give me 28 markers, that's important, and 36 crayons. And I want to divide them equally distributed. Right here, there's another clue. That might mean division. So when students come in, they're going to try to decode this type of problem, and they're going to try something with it. And actually, first they'd work in pencil, but pencil doesn't show very well in the camera here. So you're seeing me try it first in pen. After we do the problem together, students have a chance to fix it and make changes to make it a perfect paper before they turn it in. So the idea is to really learn where you are and take a risk, and then make some changes so that you can kind of push your learning. You can kind of try to advance where you are as far as your level of learning. So my work today would look something like this. I have 12, 28, and 36. Some students have looked at what we call a ladder method. Ladders are awesome because you can actually make one ladder to deal with all 3 numbers. So I say to myself, what's a prime number that goes into both 12, 28, and 36? Well, 2 is prime, and I notice all of these are even. So 2 goes into 12 6 times. 2 goes into 28 14 times, and 2 goes into 36 18 times. It's kind of like upside down division, but we're dividing all 3 numbers at the same time. I notice I ended up with 3 even numbers again, so I can divide a second time by 2. So I put a 2 on the outside here, and I say 2 goes into 6 3 times, 2 goes into 14 7 times, 2 goes into 18 9 times. Are there any other prime numbers that go into 3, 7, and 9? I notice 3 and 7 are already prime. 9 could be broken down, but the others don't seem to share a common factor. If that's the case, you already have found your greatest common factor. It can be found on the left-hand side of your ladder, and what we would do is we would take those 2 prime numbers, in this case there were 2 of them, and multiply them up. 2 times 2 will get me 4. I just found the greatest common factor. And in a minute, that might help me figure out how many baskets or groups I'm equally able to make. Another strategy for this would be the tree method. And I think most students prefer this, although you have to make several trees. So I joke that it's a forest. Here we go, 3 trees. 12 could be 4 times 3, and 3 is prime. So we break it down into its factors of 2 times 2. Well, both of those are prime, we'll circle them. Looks like this tree is done. 28 needs to be broken down because it's composite. So I could call this 4 times 7. No, 4 is not prime. I need to break it down again into 2 times 2. Oh, there are those 2's again. Those are prime. And 7 up here, can it be broken down? No. 1 times 7 is all that would work. 7 must be prime. 36. Well, lots of different possibilities, but maybe I see that it's 6 times 6. 6's are both composite, so we break them again. 2 times 3 and 2 times 3. Well, 2's I know are prime. 3's are prime also. Looks like this tree is done as well. I joke with students that all good trees can be chopped down, meaning that the next step is to line up your factorizations. So here I'm going to say 12 is the same as 2 times 2 times 3. You'll notice we're using multiplication symbols that look like dots. instead of the evil x. I joke about that. We save the x for algebra. 28 is the same as 2 times 2 times 7. Make sure you grab all those prime factors from your tree. 36 is the same as 2 times 2 times 3 times 3. Next, for this problem, I was really looking for the greatest common factor. So the number that they all share. Well, I noticed that each of them has a factor of 2 in their prime factorization. Oh, I noticed another group of 2 in their factorizations. Oh, I noticed some 3's over here. Should I circle them? The answer is no. If you notice, 3 is not a prime factor or part of the factorization of 28, so it won't work. 3 shows up a couple times for 36, but it sure doesn't show up in 28. I cannot circle the 3's. Next, I take these bundles that I've made, or these groups, or sometimes we call them pairs, but because today we're working with 3 numbers, we might call them triplets. I take these triplets and I record them once. So one group of 2, a second group of 2. And again, we're looking at factorization, so I always joke with the students, factorization goes with multiplication. We're going to show multiplication here. Well, 2 times 2 actually is 4. And if you notice, I really found the same answer here using my ladder method, or here using the tree method. So what's that mean for me? It means that I could take the 12, the 28, and the 36 items, and I could split them into 4 equal groups. Not everyone will want to model this, but it's just a way of thinking that I've seen students do recently. I'm going to make my 4 groups. Here they are. That's also the same as part A, 4 baskets. Maybe activity baskets if I want to be a little more formal. So I can make 4 baskets. Here I'm showing them. Well, I have 12 of something. I have 12 coloring books to split into 4 baskets. That's kind of like saying, what's 12 divided by 4? And then the lights go out because I'm not moving around enough in my classroom. Let's see if we can get that to go back on. So what's 12 divided by 4? The answer is 3. It looks like I'm going to put 3 coloring books in each of those baskets. And maybe I just write coloring books in a shorthand. Almost like algebra notation here, coloring books. Well, then I had 28 of something, 28 markers. It's like I'm taking those 28 and I'm dividing them into 4 equal groups. Well, 28 divided by 4 is actually 7. So I'm going to have 7 markers in this group, 7 markers in this basket, 7 markers in this group, and 7 markers in this basket. I'm almost there. There's 36 of something else, 36 crayons it says. We're going to split them into 4 equal groups. 36 divided by 4 is 9. Looks like I get 9 crayons in each of my baskets. So part B actually said, how many of each supply will go into the baskets? Well, this is interesting. I could also see that in another location. If you look right here on my factor ladder, the pieces that are remaining actually are the answers to each item, meaning there were 3 coloring books, 7 markers, and 9 crayons. Another way to see it is sitting right here. There was 3 left over in the factorization of 12. There was a 7 left over in the factorization of 28. And what about this 3 times 3? Well, that looks like 2 factors, so what we would do is we'd combine them, and 3 times 3 is in fact 9, like our coloring books. Well, we're ready to answer part B. It looks like each basket could have 3 coloring books, 7 markers, and 9 crayons. And this is kind of shorthand here. I probably could say in a more formal sentence, that is how many in each basket, or each of my 4 baskets. And that's the basic start. So again, if students didn't do this at this point, they would break out their pens, we would send a couple students to the board, we'd look at different strategies and discuss which kind of corrections we could make, and students are expected to make those changes on their paper. Maybe even show another way of solving the problem if they'd already done it once. So what's writing to learn? It's really explaining your procedure, explaining your steps. So in this situation, I somehow want to talk about the story problem. I want you to know what Lisa was trying to do. I somehow want to talk about whether I'm going to focus in on my ladder method or the factor tree method. I want to explain to you how I did that sorting or how I broke up the numbers. So I might start by saying we were given 3 different supplies to sort equally into baskets. Sorting tells us to divide. I want to find the most baskets possible. So maybe I wanted to find the most baskets possible. So I thought of finding the GCF, or greatest common factor, first. To do this, I used a factor ladder. So I'll just try to walk you through one of the steps that I used, one of the strategies. And that's all students are expected to do, talk about one of the methods they used. So to do this, I used a factor ladder. In the ladder, I listed 3 composite numbers. Probably could have made this better by using word form of that 3, huh? 3 composite numbers. And what were they again? 12, 28, and 36. I chose to divide them each by 2 because 2 is prime. Next, I took the remaining quotients. Those might be called quotients because we were using division to find them. The remaining quotients, so we're trying to use some math vocabulary when possible. The remaining quotients of 6, 14, and 18, and divide it again. By 2. This left 3, 7, and 9, whoops, at the bottom of, probably have to turn over here. Our ladder. These represent the amount of each supply used per basket. Next, we probably need to talk about the greatest common factor, or how we found the number of baskets. I also used the 2 factors of 2 and 2 to find the greatest common factor, or the most baskets that could be made. Two times 2 got me 4 baskets total. I found Lisa can make 4 baskets at most. With, I have to go back here and figure out how many she used. 3, 7, and 9. With 3 coloring books, 7 markers, and 9 crayons in each. I'm not going to pretend this writing is perfect, and again, I don't expect student writing to be perfect. Sometimes it doesn't have to be this lengthy either, but the idea that I'm really trying to encourage with them is details and explaining their thinking or their strategy. It's also a good way to kind of check to see that they understand why they're using that strategy or where it came from. That's why I try to always get them to state why they decided to divide or add or subtract or multiply. So again, just trying to give that reasoning and that strong explanation for why they did what they did makes our learners that much more prepared to communicate their thinking. Students, lastly, would be expected to make those changes. They can edit their writing, they can add to it in pen, and when they're done, they rate themselves. They decide whether they're a 1, 2, 3, or 4. Notice we use Roman numerals. We're starting to introduce this idea of quadrants in the classroom. So a 1 means that I don't have it yet. I don't understand quite yet. It's something that I need to continue to work on. I was able to copy down what the teacher and the students showed at the board, but it's something that's not my strong suit. A 2 means that I kind of get it. There are bits and pieces that I'm starting to understand. I'm having some trouble with the trees. Once I get them down, I forgot to line them up or something along that line, and I wasn't sure where to go from there, but I could at least get trees started. I started something. A 3 means I'm almost there. I almost have this figured out. A 3 sometimes means I can do the math, but gosh, I'm having a hard time communicating my steps. Or sometimes a 3 is saying, well, I kind of got stuck at the end of my math, but I was able to write about what I did. And a 4 means I have it. I totally got this. I could teach the class, I could help a friend, I understand it that well. So I think for myself today, I might be somewhere around a 4 because I was able to show 2 strategies. I was able to make some changes in pen. I did some pretty thorough writing, probably could be improved if I did a quick proofread and tried to touch it up with a little more vocabulary or a few more steps, or maybe even simplified it a little bit just so it's a little more cleaned up for someone else to read. This is the basic idea behind our warm-up each day.